Hello, hey everyone. Today we're going to learn SP number 6, which is implementation of NLP using Python libraries. So to implement the NLP technique, we can use Scikit-learn by focusing on a task such as test classification, clustering, and feature extractions. So what software we have used is Python Scikit-learn library NLTK for test preprocessing, and Matplotlib, which is used for data visualization. So as we can see that this experiment is used for Scikit-learn to explore the key natural language processing, which is NLP task, which test preprocessing techniques like tokenization, stopword removal, and stamping clean raw data. So let's learn what is Scikit-learn. It's a Python library widely used for ML, offering tools for data preprocessing, model training, and evaluation. Test preprocessing used for preparing a raw data for analysis by applying techniques like tokenization, stopword removal, and stemming. Feature extraction means transform the test into a numerical data using count vectorization and TF-IDF vectorization. So same for test classification, which uses multinomial naive Bayes algorithm to categorize the test into predefined labels with performance measured through metrics like precision and recall. Clustering, we use k-means group test document based on feature similarity and revealing patterns in unlabeled data. So let's see the test, the task. Yeah, okay. So let's go to the program. So this is our program. So I run the program so you can see. So first we have to pip install Scikit-learn and the NLTK and Matplotlib. So as you can see, my screen says recommend always satisfied because I just now installed it. So I ran it again. So it's saying I already ran. I already have the packages. When you run it for first time, it won't show like this. But you why? Because it will take time to load all the libraries. But after you run it again, like you get the same results like I'm showing now. So after importing the dependencies, you have to go to the nested line. So we have to import NLTK. From that library, we're importing NLTK corpus from stopword and NLTK tokenizer from import tokenizer and NLTK stem from porter stem. And we have to download these files NLTK download path, NLTK download stopword, NLTK punter. And we're giving a sample test. Natural language processing enables machines to understand and generate human language. So after that, we are giving tokenization and removing the stopwords. So we give for stopwords, we're giving a function set stopwords wow, which is English. So token is equal to word tokenizer test. So word tokenizer is a command, and after that we are filtering a token by using the command word for word in token if word lower, not in stopwords. So after removing the stopwords and tokenizing, we are applying stemming. So stemmer is equal to porter stemmer and creating the stemmer tokens by stemmer.stemword for word and flutter token. So after doing this functions, we are printing the stemmer tokens. So as you can see, my stemmer core tokens are Natural language process enable machine understand general human language. Here you can see that the E word is missing. So that is because the E is ends with the full stop, which is not a great thing. So as it says that it is not an English word, so that letter is being removed. So here it says download pack, everything is up to date. Next we are going to use feature extraction and importing the counter vectorization and TF-IDF vectorization. Here we're giving the some example files and then using the counter vectorization and then printing the count of the array and then using the vectorizer to transform the vectorizer and then printing it. So here we get counter vectorizer features in the numbers, and for TF-IDF we get decimal point values. This is the output of the second task. So the third task is using SQL model to import the train test split. Why we are using this tool? We are checking how much precision and accuracy of this pro documents. So for that only we are using this train test and multinomial classification report. So after importing the dependencies, we are giving the sample test and giving the labels also. What label is just to make it 0 means Python, 1 is means Java editor. So we're giving label x train x test, y train y test is equal to train test state test label test size equal 0.2, random state is 42. So after converting the test to feature vectors using IDF, the vectors is equal to TF vectorizer and x train is equal to vectorizer dot fit dot transform x. X text is equal to vectorizer dot transform x train. And creating a model, then we're training the name based classifier using multinomial assigning CLF and CLF dot fit is equal to x train and y train. To make prediction and evaluate the classifier, we are using y predict is equal to CLF predict x test that dot TF-IDF. I'm printing the classification report of y test and y predict. So we're getting the precision and recall and F1 score and support. The J is for Python and the one is for Java. So we're getting the accuracy for 1. Macro accuracy is also 1. So weighted up weighted accuracy is 1. So I think this thing is more likely uh, Java related rather than a Python related. Thank you. And then the final text task, we are checking how much cluster can we fit in this experiment. So after giving a cluster is 2 only, so we're getting a number 101. That is how we got here also 101. So that is all, friends. Thank you.